Good morning, everybody. So for this section, we're only going to take notes. There's not going to be a worksheet. There's not going to be a quiz. It's just the ed puzzle with the questions on it. So please make sure that you guys are taking very good notes on this section because you are definitely going to see it again in geometry. We're just going to try to get through this so that we can move right on to polynomials because you need that as well. So please make sure you have a notebook in front of you and a writing utensil. So you're going to be able to simplify square roots by applying the product and quotient properties of square roots. You're going to be able to add and subtract and multiply radical expressions. So before we go into, you should know what a radical is. It's the square root. But before we go into any of that, we're going to go over the product property of square roots. We're going to go over the fact of how you put them together and break them apart. So to put them together, you may have the square root of a number times the square root of another number, and it's just those two numbers multiplied together under the square root. So an example of this would be the square root of 4 times the square root of 9, which would equal the square root of 4 times 9, and 4 times 9 is 36, so you would get the square root of 36. Now, to make it a little easier, if you know what the square root of 4 is, you know that it's 2, the square root of 9 is 3, and the square root of 36 is 6. So another easy way to look at this is to just look at 2 times 3 equals 6, which is your final answer for that one. So that's how you are able to put together multiplying two square roots. Breaking apart. Again, now this is the opposite way. You may have a whole number and you're going to see which two terms multiplied together will equal that. So just for example, using the same example, we have the square root of 36, which can be 4 times 9, which will be the square root of 4 times the square root of 9. This list right here is going to be your best friend throughout this section. You're really focusing on our numbers in red. So these numbers in red right here are your perfect squares. So 1 squared is just 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And you know that square means that it's 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, and so on. So these red numbers are the most important numbers that you want to focus on in order to break down and simplify your radicals. So here are some examples. Our first example is the square root of 25. So if you take a look at, where the 25 is, working backwards, the black number above 25 is 5. So the square root of 25 is 5. The square root of 81, looking at our red list, finding out where 81 is, seeing that the number backwards, if you were working backwards, the number would be 9, so the square root of 81 is 9. The square root of 121, looking at our red list, seeing where 121 falls. 121, working backwards, is 11. And finally, the square root of 196, looking on our list to see where 196 falls, working backwards, the square root of 196 is 14. Okay, so that's kind of how you use this list. If you're trying to find the square root of a perfect square, those numbers on the top row, all in black, those are your numbers that come out of the square root. Your red numbers are your perfect squares that typically go inside the square root. So now we're going to simplify the following square roots. So the square root of 12, okay? The square root of 12 is not in our list in red, so it's not a perfect square, but we can find our largest perfect square that goes into 12. So the first thing I'm going to do is point out where 12 falls on my list. 12 falls between 16 and 9. So from here, I'm going to go left, I'm going to go down to see what my largest square root is, what my largest perfect square is, that goes into 12. So 12 divided by 9 does not come out evenly, but 12 divided by 4 is 3. So 4, because when divided by 12, 4 comes out with another number, a whole number, we can say that 4 is our perfect square that we're going to use. So we can split 12 up into the square root of 4 and the square root of 3. Simplifying that down, the square root of 3 stays in the square root because it's not a perfect square, but the square root of 4, since it is a perfect square, comes out of that square root and becomes 2. So my final answer here is 2 times the square root of 3. Same deal with the square root of 27. Square root of 27 is not a perfect square, but I'm going to see where it falls on my list. The square root of 27 falls between 36 and 25, so now I'm going to work my way down the list. 25 does not go perfectly into 27. 16 does not go evenly into 27, but 9 goes into 27 3 times. So I can split 27 up into the square root of 9 times the square root of 3. The square root of 9 right there is my perfect square. So we're going to take that out of the square root, and I'm going to get 3 times the square root of 3. Same thing for 50. I'm going to see where 50 falls in my perfect square list. I'm going to go down to the left and see what perfect square goes into 50. 49 doesn't go evenly into 50. 36 doesn't go evenly into 50, but 25 goes into 50 2 times. So I can split 50 into the square root of 25 times the square root of 2. And I'll end up with square root of 25 being my perfect square. When it comes out, it becomes 5. So I'll end up with 5 times the square root of 2. 72 falls in between 81 and 64. Going down my list, 64 does not go into evenly into 72. 49 doesn't go evenly into 72. But 72 divided by 36 is 2. So my perfect square is going to be 36 times the square root of 2. That's how I can break up the square root of 72, which becomes 6 times the square root of 2. And then finally, 200. 200 is going to fall between 225 and 196, and I'm going to work my way down my list. So 200 divided by 196 is not an even number. 200 divided by 169 is not a whole number. 200 divided by 144 is not a whole number. 200 divided by 121 is not a whole number, but 200 divided by 100 gets me 2. So I can split 200 into the square root of 100 times the square root of 2, which will end up as 10 times the square root of 2. So I'd like you to try this one on your own using your perfect square list. Go ahead, try this one and put it right into Edpuzzle. Submit your answer. Once you submitted your answer, you'll see that the square root of 52 can be broken down into the square root of 4 times the square root of 13, which is 2 times the square root of 2. I'd like you to try this example as well. Square root of 45. Once you're ready, you can submit your answer into Edpuzzle. The square root of 45 can be broken up into the square root of 9 times the square root of 5, which will get me 3 times the square root of 5. So now we're going to be multiplying our square roots. When you're multiplying your square roots, we're really putting them together. So the first part that I taught you is breaking them apart. Now we're working backwards and putting them together. So I'm going to go ahead and multiply the 2 and 24 and keep it under the radical. When I do that, I'll get the square root of 48. Using my perfect squares list from before, so hopefully you guys wrote that down in your notes. If you didn't, go back and write it down. Using my perfect square, I'm going to see what is the largest perfect square that goes into 48. When I do that, I'll get that 48 can be broken up into 16 and 3. Okay, 16 goes into 48 evenly 3 times. 16 is my largest perfect square that goes into 48. You always want to make sure to use your largest perfect square. If you were to use 8 in this situation, or if you were to use 4 or a different number, it wouldn't come out to the simplest form. So always use your biggest, largest perfect square number, which is why you always want to work backwards. So this will become 4 times the square root of 3 once it's simplified. Here's another example. 5 times the square root of 35. Why don't you try that one and submit it into Edpuzzle? So when you do that, you'll get that you multiply 5 times 35 and you get 105. 105 can be broken up into 25 and 7, which will then become 5 times the square root of 7. So these are just some really quick notes on radical expressions. I will be posting another video. There's a teacher that I really like on Instagram, and she's been working with radicals as well, and she has this fun little game that I'd like you to try. I'll give details on that on Google Classroom, but for right now, as long as you answered the questions, you are all set. Please answer this last question so I know how you guys feel about this content. Thank you.